Hi everyone, and welcome to another example or practice problem of nodal analysis. In this question, we want to find V0, which is the voltage between these two nodes that we can see them, or the voltage across the 5 ohm resistance. Okay, now let's recap what we said about the procedure to apply nodal. First, we need to select a reference point. So the negative side of voltage source is always an ideal location because this will help us to eliminate one of the nodes and find its value. So this is will be your V equal to 0. Okay. Number two, assign nodes for or voltages for all other nodes. So this will be your V1. This will be your V2. Now this I will not assign a variable because I already know the value. So this will become equal to 10 volt. And this will become your V3. So what do we have here? We have basically three unknowns, V1, V2, and V3. So I will need three equations in terms of V1, V2, and V3. Okay, so basically we want to find V out, but V out is nothing but V2. You can see that, but I prefer to use the nodal voltages. And then after I found the nodal voltages, then I will go and see what I want to find in the question, and then uh, correlate the requirement with the node voltages. Okay, now we want to apply KCL to these nodes. Remember, we don't apply KCL to a node that is connected to a voltage source. Why? Because this voltage source, I need to assign a current to it, another variable to it, so that I can apply KCL. So I will add an equation with another variable. So I'm complicating the problem and by increasing the dimension of the number of equations, and you don't want to do that. Okay. So V1 is basically connected to the positive terminal of this dependent source. So I cannot apply KCL to V1. V2, no, it's not connected to any voltage source. So the first equation, I will apply KCL at your V2. Now, as I mentioned before, we assume all the currents are leaving. So this current is leaving, leaving, and leaving. So to the left, we have V2 minus V1 divided by 2 plus to the right, V2 minus 10 divided by 10, okay, the bottom, plus V2 minus 0 divided by 5, and this is equal to 0. We have three branches connected to the node V2, then we have three items. Perfect. Now I want just simplify the equation, just multiply by the least common denominator. So I will multiply by 10. So we will have here 5 times V2 minus V1 plus V2 minus 10 plus 2V2 equal to 0. Let me collect terms. So we'll have minus 5V1 plus 5V2, V2, 2V2 plus 8V2. And this is will equal to 10. So this is my first equation. In terms of V1 and V2, perfect. I need two more equations. Can we apply KCL to 10 volt? No, because it's connected to a voltage source, and we already know the voltage here at this node. Can we apply KCL at V3? Also no. Why? Because it's connected to the negative side of the dependent voltage source. So this is how many equations I can get from regular nodal analysis. Okay. Now let's go to the voltage supply and let's work the super node and the relationship between the two nodes that is connecting this voltage supply. So basically, the voltage supply is between V1 and V3. So basically, V1 minus V3 is equal to what? Is equal to 3IB. V1 minus V3 is equal to this voltage. But IB is another unknown. I don't like to see IB in the equations. I want to eliminate IB. So what is IB? Okay, so what is IB? IB is the current going between V1 and V2. So IB is equal to V1 minus V2 divided by 2. Okay, excellent. So now I will substitute IB in this equation. Okay, so I will take the value of IB here and I will come and substitute it here. Okay, so your V1 minus V3 equal to 3 times IB, which is V1 minus V2 divided by 2. Excellent. So I will multiply everything by 2 to get rid of this 2 in the denominator. So we'll have 2 V1 minus V3 equal to 3 times V1 minus V2. I can take this side of the equation to the other side, the left to the right side. So we'll have 3V1, 2V1 going to the other side becomes minus. So we will have V1, okay, and then we will have here minus 3V2 and then plus 2V3 equal to 0, and this is my second equation. So now I have two equations in terms of V1, V2, and V3. We need one more equation. Okay, let's go back here. This is your V1, and this is your V2, 10, and your V3. Okay, so we'll apply KCL now to the super node that comprises nodes 1 and 2. So we look here, all of this now become one node. So we will hide, sort of hiding the voltage source here, and all of this become what? Become one node. Okay, so we don't care what is happening in between V1 and V3. So all of this like becomes one giant node. So we have here 1, 2, 3, 4 branches connected to this giant node. So we'll apply KCL to this super node, and we expect 4 items. Okay, so to the right, IB. No, don't write it in terms of IB. We'll write it in terms of V1 and V2. So this becomes V1 minus V2 divided by 2. No more IB. Now, the 15 amp is entering the node, so this is minus 15. I cannot play with the direction of the current source. This has to stay the same, the whole equation or the whole question. Now, this is done, so to go to the other side, plus to the left, V3 minus 10 divided by 1 to the bottom, plus V3 minus 0 divided by 3 equal to 0. So multiply by the least common denominator, multiply by 6. So this becomes 3V1 minus V2 minus 90 plus 6V3 minus 60 plus 2V3 equal to 0. Now let's add terms. We have 3V1, we have 3V2 minus sign, then we have 6 and 2, so plus 8V3 minus 90 minus 60 is equal to 150, and this is our third equation. So now we have 3 equations with 3 unknowns. Our electrical part is done. Now let's start the math part. Okay, so we have 3 equations. We can bring equation number 2 and eliminate V3. So equation 2, what it says here, it says V1 minus 3V2 plus 2V3 is equal to 0. This is our second equation. Now, if I can eliminate V3 from here, then I can have equation in terms of V1 and V2 only. With equation 1, then I can eliminate another variable and then start to find our variables. Of course, this is one way. You can do it in a different way. So the math now is up to you how you want to proceed. So to get rid of this, I will multiply equation 2 times 4. Okay, so I will multiply equation 2 times 4. So what we will get here, we will get, when we do that, 4V1 minus 12V2 plus 8V3 equal to 0. I will call equation, this is equation number 4. So we'll have this 4 and 3. So what I will do, I will just subtract. So when I subtract, it becomes minus V1 okay, and then plus 9v2 minus 3v2 minus 12, so plus 9v2 equal to 150, and this is my fifth equation. Excellent. So let me bring equation number 1, which is minus 5v1 plus 8v2 is equal to 10. Now remember, I want to find v naught, which is v2. So if I eliminate v1, find v2, my problem is solved. So this is my first equation to how to eliminate v1. If I multiply v1 with 5, subtract, or multiply by minus 5 and add, okay, so I will multiply this with minus 5. So what I will have here, 5v1 minus 45v2 equal to minus 750, and I will have here minus 5v1 plus 8v2 equal to 10. So this equation, I will just add them. Okay, so this will cancel. So we'll have minus 37 v2 is equal to minus 740. So your v2 is equal to minus 740 divided by minus 37, and this is equal to 20 volt. And this 20 volt basically is your V2. Now, if I want to find V1, I can use this equation and then go back and find V3. But my question is find V naught. This is your V naught, and my problem is solved.